Tyler Carden with Engineering and Virtue.
For my capstone, I decided to explore aerospace engineering. A couple months ago, I knew I had a capstone project coming up, and I wanted to use that opportunity to narrow down my career choice. I had it narrowed down to being a physician, doing some sort of bioengineering, or doing aerospace engineering. I knew I'd make a great physician, but it was more based off a salary decision, not off of a passion. I find bioengineering very interesting, how people can clone animals and bring them back from extinction, but I do have some ethical reservations about that. But aerospace engineering seemed like a good fit for me. I'm more interested in the physical sciences rather than the biological sciences. I've always enjoyed looking at space and traveling around the world and looking at the stars from different hemispheres, different perspectives. Even my elementary bedroom had planets and stars painted all over them. Aerospace engineering can be divided up into two categories. There's astronautical engineering, which deals with vehicles outside the atmosphere, like probes and satellites, and aeronautical engineering that deals with vehicles in the atmosphere or planes and various other flying objects. Aerospace engineers design things from missiles to probes to satellites to aircraft, like the Juno probe up here. It was designed by NASA and Lockheed Martin to study the mysterious planet Jupiter. What I can show you is the beauty of Jupiter, but what I can't show you is the dangerous radiation surrounding Jupiter and how it's messing with the instruments. Space is dangerous, beautiful, and attractive, and repelling all at the same time. Some of the best, there are great engineering schools all around the world, but some of the best for aerospace engineering anyway include MIT, Georgia Tech, and Purdue University. An aerospace engineer can work for the government or for several different companies like SpaceX, Boeing, or Lockheed Martin. They usually work government contracts working for the government. I tried to get, for my entire first semester, I tried to get a hands-on activity I could do with engineering. And I couldn't get it short of a miracle. I was talking and emailing to several people. There's just a lot of red tape and bureaucracy around trying to get a teenager in for a couple hours to try and help. Through that experience, I really learned to be more patient, realize things were out of my control, become more slower to anger through those experiences. Even if there's a slow or a bad driver in front of me or I spill food on myself, I realize that it's out of my control and it shouldn't stress me out. But a hands-on activity I did end up doing was an egg drop activity with 8th graders at our school. But they were divided up into several different groups. Half of the groups had parachute materials and the other half had just materials to cushion the fall. I wanted them to see that there are several different ways to slow down the egg so it wouldn't break on impact. I really enjoyed seeing the creativity of the designs that they came up with. I noticed that they discussed their ideas a lot more than they actually were building the structure. That might have been just due to just not using their time wisely, but discussing and ideas is very important in engineering. Engineering is all about teamwork, because whether it's building a Juno probe or it's building an egg structure, it all requires teamwork. And with teamwork requires discussing ideas. And discussing ideas requires elegance, love, and patience when trying to get people to understand what you're saying or trying to understand what someone else is saying. And you have to be diligent in your work and do the job assigned to you. Sure, in the real world, there's lead engineers, but they still have to work with teams. In addition to that experience, I talked with one of my dad's friends, Dr. Riatort. He went to Virginia Tech and got a mechanical engineering degree there. Also has a graduate degree in engineering. He eventually did go to medical school because he didn't like all the bureaucracy and meetings surrounding engineering. But what he did teach me what it was like to study engineering, what engineering is all about. Engineering is all about problem solving. He said all of his tests and quizzes during engineering school were all open book because he didn't have to memorize much, he just had to know how to solve the problem. And problem solving is a good skill to have, whether you're trying to put a probe into space or you're trying to fix a leaky faucet at home. He also taught me the importance of work ethic in engineering as well as throughout daily life. He has obviously several degrees in engineering and a doctorate degree, and he's worked hard throughout his life. And when I was talking to him, he recommended that I double major and do internships every year and get master's degrees, which seems like a lot of work. But I'll probably do something similar to that, but not to that extreme. But he said you'll notice the pain and the torture of the hard work in the moment, but you'll notice the payoff in the future, whether that's your dream job or your dream salary. So both good work ethic and problem-solving skills are very important in engineering as well as in daily life. Engineers have a great potential for massive failure and massive success. It's the difference between landing on the moon and having a bridge collapse. Engineers need to know how to learn from their failures. Hopefully that's in a testing and an experimental environment. So when their engineers are running tests, they need to know how to learn from their failures, and they also need to know how to build a reliable and repeatable test, and they need to be patient, persistent in designing their structures and experiments. And they also have to know when they know they're right and when they have reached a good solution, so that they eventually have to build that bridge or build that structure. There are many different ways to test or design a structure or an object, and engineers need to be efficient and very simple in their designs, whether that's one solution or another. I also researched a couple significant figures surrounding aerospace engineering for the second part of my capstone project. I would like to talk about Elon Musk and his mission. His goal is to eventually colonize Mars by delivering cargo to the ISS, to the International Space Station, and using the profits from that to build reusable rockets to make it cheaper to go to Mars. He's revolutionized the electric car industry in a few short years, and he landed a rocket vertically in a few short years as well with his team of engineers. Before we started exploring Mars or exploring the moon, we didn't know whether people went crazy in weightless environments. We didn't know if the moon was just a ball of dust or it was solid. We didn't know what the Earth looked like from space. We didn't know what the Van Allen radiation belts were before we started space exploration. NASA has helped develop things from firefighter gear to highway traction. So in addition to the good things that scientific discovery can do, especially space exploration, the space race in history really exemplifies the bad things that can go wrong with aerospace engineering. Space race can be divided up into the stories of two men, Wernher von Braun, who worked with Germany and the United States, and Sergei Korolev, which worked for the Soviet Union. I'll start with von Braun. His story starts in Germany, working as a teenager, building rockets. The German government at the time, during World War II, the Nazis recognized his talent and recruited him to work on Hitler's wonder weapon, or a long-range missile for him. He used the Nazis as an opportunity to develop his rockets and eventually explore space. But there are some ethical problems with what he did. The V-2 rocket on the right here, it was used to kill civilians, and it was also made with slave labor, where people were given less than 1,000 calories a day and very little water, constant executions and poor conditions. They worked in caves. So he kind of ignored the ethical problems with building this rocket for his definition of the greater good, which would be exploring space in the future. He eventually escaped Germany and worked for the Apollo missions and for the United States. He put Alan Shepard into space, put John Glenn into orbit as well. The other side of the space race was the Soviet Union with Sergei Korolev. He also began designing rockets as a teenager, but he was sent to the Gulag, or Soviet work camp, because he was accused of being involved in an anti-Soviet organization. He helped put the first person in orbit, helped the first person do the first spacewalk, and helped get photographs of the back of the moon. This rocket was used to put the first man in space, and that was one of the first. Was the first satellite put into space that he helped develop. The interesting part of the Soviet Union and his story is also the poor working conditions that the Russians worked under while working with this rocket program. The pipe that was used to distribute water was also the pipe used to fuel the rockets. So all the water tasted like kerosene. They had poor shelters, and because temperatures range from -20 Fahrenheit to 120 Fahrenheit. They worked 15-hour days. People were constantly falling off platforms and making simple mistakes that ended up in several deaths. They compensated by drinking, and drunk workers don't make for good workers. The Russians also had very little resources, and so they often resorted to using tricks to seem like they were ahead of the Americans at the time. For example, they put two capsules in orbit right next to each other, about 3 miles apart, to make it look like from Earth that they knew how to dock in orbit. They also put 3 people into a one-person capsule to make it look like they had a multi-person capsule and were able to put several people in space, which wasn't entirely true. So there's definitely something to be said about the virtues involved in the processes of engineering, whether the problem seems small or large. You can't ignore the little things for the greater good. It's hard to determine the ethics of war and aerospace engineering because there's no direct Bible verses on engineering, but one must follow biblical principles to show the heart of God in their work, whatever that is. Engineers built things from the atom bomb to the Tower of Babel. It's just a matter of determining whether it's good for humans or not. Ultimately, engineers reshape the conditions of human experiences, as phrased by the Dean of Engineering at Purdue University. I noticed there's a relationship between truth, loyalty, betrayal, and sacrifice, as exemplified in the space race. These rocket technologies are weapons technologies, and they can't get in the hands of an enemy, and it would be very disastrous. So countries and people value loyalty above anything else. Sacrifice is one of the ultimate signs of loyalty. There's a reason why the astronauts and the cosmonauts were celebrated by both cultures at the time, because they were showing the ultimate loyalty to their country and the ultimate sacrifice for the greater good. The worst thing a human can do is betrayal, and it's the opposite of loyalty. And this is exemplified by the fact that von Braun was questioned his entire life in America for being a Nazi in his past life, and he got a lot of scrutiny because of that. And the same with Sergei Korolev. He was sent to the Gulag for even being questioned for being anti-Soviet. The relationship between betrayal, loyalty, and sacrifice is also exemplified in the resurrection story, starting with Judas's betrayal and moving into Jesus' sacrifice, and how Jesus' sacrifice and the love shown through that can even trump the worst of sins, like the betrayal of Judas. Aerospace engineering has a great potential for evil and great good because it plays with the traits that humans value and scorn the most: sacrifice and betrayal. Ultimately, there are two ways to know God. You can study His creation, or you can study the Bible. I've seen how science lines up with the Bible, and I've seen how things like general relativity can line up with biblical teachings. Ultimately, what I want to do is help people understand God's creation by studying it and exploring space, like Galileo and Newton did with their discoveries. The beauty of God is shown through engineering. Um, seeing the galaxy, seeing the full Earth for the first time. The first person in space, a Russian, described the blackness of space next to the bright Earth and a shimmer of a rainbow from the sun reflecting off of it. People often look for a sense of wonder when in their daily lives, that emotion people desire. It's what makes people feel small and recognize their place in the universe. And exploring space and aerospace engineering has one of the greatest potentials for showing wonder to people and God's beauty. Expanding knowledge of God's creation also expands His kingdom. Psalms 11:2 says, "Great are the works of the Lord, and they are pondered by all who delight in Him." And Psalms 19:1 says, "The heavens declare the glory of God, and the skies proclaim the work of His hands." These psalms, people can use engineering to ponder God and explore His beauty and explore His creation and try to understand Him by studying His creation, or you can use it for great evil, like the space race was for some of them. Ultimately, what people need to do is determine the biblical principles in their daily lives and show the heart of God in whatever they do, whether it be engineering or trying to fix a leaky faucet. Thank you.